Yes, hello, Mr. Raju Burman. Let's start your snap for thermodynamics. As you mentioned, you are preparing for BEML and you are having your interview on 23rd of this month, January.
Yes,
So,
sir.
Raju, in thermodynamics, we study different laws actually. First law, second law, third law, zeroth law of thermodynamics. So, can you tell me brief about all these laws of thermodynamics?
Sir, zeroth law of thermodynamics when A and B two bodies are in contact with thermal equilibrium with each other and contact third body C, then all three body are thermal equilibrium with each other.
Mm-hmm.
Or first law of thermodynamics, energy is neither created nor destroyed. Energy is transformed one form to another form of energy.
So, suppose we are using a mercury thermometer to measure the temperature.
Yes, sir.
So, that mercury thermometer you will name like a body A, B, or C.
Mercury thermometer link like C, sir.
Body C. So, what are those body A and B?
Sir, actually, A body is a industry expect body, or B is my tested body, which temperature I measured, and C is my thermometer.
What is the thermometric property in case of thermocouple? How a thermocouple works?
Thermocouple, sir, works on the Seebeck effect.
Good. Yes. Tell me brief about that.
Sir, actually, when two dissimilar metal are contact and they are heated, there
Mhm.
is some voltage difference is created, and this voltage difference we measure the temperature.
What is that first law, second law, and third law?
Uh, Sir,
Mhm.
first law of thermodynamics, energy is neither created or not destroyed. Energy is transformed one form to another form of energy. It is such a first law of thermodynamics. Or cyclic integral q equal to cyclic integral w.
Mhm.
Sir, this is for cyclic process, cyclic system, or process q equals to del u plus w. This is first law of thermodynamics for process.
Mhm.
Or second law, sir, according to the second law, two type of law. One is Kelvin Planck statement, one is Clausius statement.
Mhm.
Kelvin Planck statement, when heat engine operate on a cyclic system,
Mhm.
operate on a cyclic process, uh, the uh, single thermal reservoir interaction is not possible.
What do you understand by continuum? Continuum concept.
Sir, continuum means molecular level analysis.
Mhm.
Actually, it's depend upon the character molecular interaction by characteristics length. It's depend upon the Knudsen number. When
Mhm.
Knudsen number less than 0.01, this is called continuum, or when the Knudsen number greater than 0.1, this is not a continuous.
Now, just suppose we are interested in carrying out some thermodynamic analysis in the room in which you are sitting.
Yes, sir.
So, can you tell us this room you will consider as a what kind of system? Closed system, open, or isolated, and why?
Sir, actually, this room depend upon the condition. When the room is then energy or work, not
Mhm.
transfer.
Mhm.
This system daily equals to zero, constant internal energy, actually.
Mhm.
Or when the room uh, mass transfer or energy transfer both are available, then we consider open system. And when only energy is transferred, mass is not transferred, then we called as a closed system. We taking the room as a closed system.
So this room you will consider as a open system.
So actually, when mass and energy is such a transfer. Sir, it's depend upon the condition.
That's why I'm asking you. You will consider this room as a open system or closed system? All
Sir,
conditions are
sir,
there in front of you. You can see, you can observe.
sir, actually, in this such a situation, it's a closed system.
Closed system. Why? Why closed?
Because sorry, sir. Actually, in this situation, it is such open system. Mass interaction is available, and which energy is also such a transfer.
So fine. Then how you will write the energy balance? First law of thermodynamics for that open system means your room. You need to consider all these all kind of work and heat interaction.
Energy. First law of thermodynamics for H1 H1 plus. At first, sir, such a enthalpy.
Means you are considering your room as a steady flow system.
Yes, a steady flow system. H1 plus V1 square by 2.
So how you can say that your room is in steady state?
Sir, steady state depend upon the when something like something property dot change with respect to time. This is called unsteady state, or some property do not change with respect to time. This is called steady state.
So you are considering your room is in steady state.
Actually, sir, it's depend upon the conservation of mass in and mass out. No mass accumulation in the room. So this system is called open system.
And how you will write the energy balance?
H1 plus V1 square by 2 plus some heat input equals to H2 plus V2 square by 2 plus work output plus some amount of work.
Work output. So is there any work output from the room?
No, sir. Work is 0.
Work transfer is 0.
Work transfer is 0.
There is no work entering inside your room.
Sir, actually, in this open system analysis, boundary work available.
No, some electricity is flowing, is entering inside your room because you're
yes, sir. Yes, sir. Some electricity is flowing. So
electric work is entering, no? Electric work is entering.
Work is entering.
Fine. Okay. So then, what is second law of thermodynamics? What is your understanding related to second law of thermodynamics?
So the second law of thermodynamics is two type of law. One is Kelvin-Planck statement, and another is Clausius statement.
Those are not two types of law. Those are two statements.
Two statements, sir. Actually, yes. Two statements. One is Clausius statement, and another is Kelvin-Planck.
So there are only two statements for second law of thermodynamics, or there are other statements also?
Sir, second law of thermodynamics. One statement, sir. Actually, two statements. Kelvin-Planck and
but there are so many other statements like 100% the PM2
perpetual PPM one, sir.
PPM one. Process is going to execute in a direction of increase in entropy of universe. Entropy of universe is always going to increase. The quality of energy is going to degrade in a real process. Oh, there are so many statements.
Yes, sir.
Achha, go ahead. Tell me some brief about these two statements, Raju.
Sir, Kelvin-Planck statement, when a cyclic device operates between two thermal reservoir and some amount of one some actually, sir, कोई heat engine से energy मिलने के लिए two reservoir चाहिए. Only single reservoir से energy नहीं मिलेगा. यही है Kelvin-Planck statement.
पूरा अच्छे से क्लियरिटी से नहीं बता रहे हो आप राजू.
सर Kelvin-Planck statement, tell me something about Kelvin-Planck statement है. It is impossible to construct a cyclic device which can extract energy only one single thermal reservoir. It is a Kelvin-Planck statement or Clausius statement. It is impossible to construct a device or a cyclic heat pump which extract energy from a lower temperature reservoir to higher temperature reservoir without any external aided or external energy input.
ठीक है राजू, आइडियल गैस क्या होती है?
आइडियल गैस एक्चुअली सर जो PV इक्वल टू MRT ये लॉ फॉलो करता है, इसी को आइडियल गैस बोलता है।
तो परफेक्ट गैस क्या होती है? इज देयर एनी डिफरेंस बिटवीन आइडियल गैस एंड परफेक्ट गैस? ये बोथ आर सेम?
सर परफेक्ट गैस मतलब एक्चुअल कंडीशन में जो गैस मिलता है उसी को परफेक्ट गैस बोलता है।
What do you understand by thermodynamic equilibrium?
Sir, thermodynamic equilibrium is such a thermodynamic, three type of equilibrium. One is such a temperature, thermal equilibrium, mechanical equilibrium, and such a chemical equilibrium. When the temperature interaction is such a zero or a temperature gradient is zero, this situation is called thermal equilibrium. When intermolecular pressure force or net pressure force equal to zero, this is called force equilibrium or pressure equilibrium. Or when the chemical energy interaction is zero, this is called chemical equilibrium.
ठीक है राजू, मैं आपको फीडबैक दे देता हूँ। Raju, this is your like you appeared for your first snap, so I asked you very basic direct questions only.
Yes,
next
sir.
time whenever you will join, I will ask you some more questions, okay? Some more practical application of thermodynamics.
Okay sir.
तो ठीक लग रहा है अभी, it's looking fine. You answered, you are answering most of the question. थोड़ा सा अपना डिलीवरी स्टाइल को इम्प्रूव करो, है ना?
सर मेरा लैंग्वेज में कुछ प्रॉब्लम है।
लैंग्वेज में दिक्कत है, yes. So that is there even in if you communicate. Not normally also if you communicate that comes.
Yes sir.
चलो कोई बात नहीं, थोड़ा सा आराम से बोलो फिर आप ना।
तो सर ये इम्प्रूव करने के लिए क्या ज्यादा स्नैप
प्रैक्टिस? यस प्रैक्टिस, ज्यादा स्नैप ला। टेक्निकल नॉलेज है आपको, अंडरस्टैंडिंग है, और थोड़ा सा और क्लियरिटी से बताने की बात करो। जब मैंने आपको बताया कि पूछा मैंने आपसे कि वेरी करेक्टली यू हैव नॉट हाइलाइटेड व्हाट इज फर्स्ट लॉ, देन अगेन यू रिपीटेड एंड इन दैट केस यू आंसर्ड करेक्टली, है ना? So
yes,
in the beginning only you need to start with the very in a very correct manner you need to start, है ना? So that you will be able to convince or satisfy the interviewer. तो थोड़ा सोच लो टाइम लेके, just take 2-3 seconds to think and then start.
Okay sir.
Perfect gas, ideal gas. देखो, perfect gas is an ideal gas. An ideal gas with a constant specific heat, that is known as a perfect gas. एक ऐसी आइडियल गैस जिसके CPCV constant हो, CPCV both varies with the temperature. CP also increases, CV also increases, but their ratio gamma decreases with the increase in temperature. So a gas which is having a constant CPCP value, that ideal gas which is having constant CPCP value, that is known as a perfect gas. Are you getting, Raju?
Yes sir.
So perfect gas is already ideal, and that is also going to follow the ideal gas equation.
सर एक्चुअली CPCB एक कंडीशन में लिनियरली वेरी करते हैं लिनियरली। उस कंडीशन को बोलता है आइडियल गैस सिचुएशन।
नहीं, ऐसा थोड़ा ना कि लिनियरली वेरी करेंगे। आइडियल गैस इज अ गैस व्हिच obeys ideal gas equation. That is the first thing. Ideal gas is a gas in which the intermolecular force of attraction between the gas molecule is negligible. The particles are not having an intermolecular force of attraction, so they are colliding, but their interaction is zero, and the volume of the gas molecule is negligible. They are having mass, but their volume is negligible. So those are the particles of an ideal gas can be considered as a pointed mass.
Yes sir.
Okay. So there are some of the assumptions we consider for an ideal gas, है ना? So ideal gas follows those all assumptions. So some of the assumptions I highlighted with you. Real gas, there must be some interaction of the molecule. Gas molecular attraction will be less, but it will be there. You cannot say it is zero. And particles will have some volume. You cannot say that is negligible or zero. Okay. And
सर
real
एक्चुअली
gas,
रियल गैस के लिए क्या वैन डर वाल्स का जो इक्वेशन है ये
yes,
अप्लाई
yes,
होता है?
those are approximate equations. Yes, van der Waal is one of the equation we use for real gas. Pressure, volume, temperature का जो relationship है for real gas, that we express in terms of the van der Waals equation. But there are so many other equation also, but that is a van der Waal equation is the famous one. Okay, sir. So you need to have some clarity about that van der Waals equation, how we write, what are A and B in that van der Waals equation. Okay, so and basic significance of all laws of thermodynamics. What we are getting actually from all laws of thermodynamics. थोड़ा सा energetic होके बताओ. So zeroth law is a law which tells us, जैसे आपने बताया A and B C bodies. A is a experimental body. उसको industry मत बोलो. उसको क्या बोलोगे आप? Experimental or what you can say that's a experimental body, standard body. Standard body. B is what? B is a test body. The body where we want to measure the temperature. C is what? C is a thermometer or temperature measuring device. So zeroth law, sir, gives us the portable means of temperature measurement. So after the introduction of zeroth law, we can measure temperature anywhere at any place without bringing the body into the lab. Now, if we want to measure the temperature, sir, we can measure at any place. We can measure the temperature in a room, at anywhere. Okay. Okay, sir. Why? Because the temperature measuring device which we are having, that is calibrated with some lab body, that is calibrated with some standard body. Right? So zeroth law में क्या देता है? Portable means of temperature measurement. First law पे आ जाओ. Sir, first law tells us we cannot create energy, we cannot destroy energy. Creation or generation of energy, sir, is impossible. Some input is required to get the output. Without input, output is not possible, sir. That is first law of thermodynamics. And sir, mathematically we can express first law like this. थोड़ा लिंक करो. पहले इक्वेशंस पे जाओगे तो उससे थोड़ा सा अच्छा नहीं लगेगा इंटरव्यू पे. समझाओ, है ना? ऐसा लगना चाहिए कि यस यू गॉट सम अंडरस्टैंडिंग ऑफ द सब्जेक्ट. और वो आपको है, मैं बताऊंगा राजू, अंडरस्टैंडिंग है आपको सब्जेक्ट का, बट वो पहले एक्सप्रेस करो, है ना?
यस सर, यही प्रॉब्लम है मेरा, एक्सप्रेस.
कोई बात नहीं, हो जाएगा, हो जाएगा. देयर इज अ गुड पोटेंशियल इन यू राजू. और ये आपका पहला स्नैप था. मेरे को लग रहा है कि अगर आप कुछ और स्नैप लगाओगे देन यू विल इजीली गेट दैट कॉन्फिडेंस एंड क्लैरिटी टू एक्सप्रेस योरसेल्फ.
सर एक्चुअली मेरा ना कॉन्फिडेंस नहीं आ रहा है इंटरव्यू का.
आ जाएगा. अभी तो पहला ही स्नैप लगाया ना आपने.
हाँ यस सर.
हाँ, कुछ और स्नैप लगाओगे आ जाएगा. यू आर हैविंग गुड अंडरस्टैंडिंग ऑफ द सब्जेक्ट. थोड़ा थोड़ा और प्रैक्टिस करोगे तो आपको और क्लियरिटी हो जाएगी कि मेरे को बोलना क्या है, कैसे बोलना है. अभी क्या कर रहे हो? स्नैप सुनते रहो. हाँ yes,
sir, actually I am doing masters from heat power engineering in Jadavpur University. Currently I am final year M.Tech student.
तो एफर्ट्स करो बच्चे, एफर्ट्स करो. M.Tech का भी थोड़ा आपने मेंशन किया है BEML के लिए कि यू आर डूइंग M.Tech.
यस सर,
मेंशन किया है. ठीक है, ठीक है. दैट इज द रीजन आई थिंक.
सर एक्चुअली मेरा जो इंटर्नशिप था वो रेलवे में था. इंटर्नशिप के बारे में क्या डेप्थ में पढ़ के जाना चाहिए? वो
नहीं, देखो आपको पता तो होना चाहिए ना कितने मंथ का था इंटर्नशिप.
वो सर 15 डेज का था. जो वोकेशनल ट्रेनिंग होता है ना वो किया था.
थोड़ा सा होना चाहिए कि आपका एक्सपोजर किस शॉप में आपने ट्रेनिंग किया.
डीजल लोकोसेट में.
हाँ, तो डीजल लोकोमोटिव से रिलेटेड फिर आपको पता होना चाहिए. डीजल इंजन जो भी है ना रेलवे का, रेलवे में कैसे काम करता है. तो देखें ना, आस्क यू सम क्वेश्चन लिख है. तो अभी क्या करते हैं आप, या तो अलग से स्नैप लगा लेना कि सर आज मेरे को स्नैप देना है अपना इंडस्ट्रियल ट्रेनिंग की रिलेटेड रेलवे में. तो आई विल आस्क यू कि आपने कहाँ ट्रेनिंग किया, क्या सीखा. देन सम रिलेटेड क्वेश्चन आल्सो आई विल आस्क यू. तो स्नैप क्या होता है? स्नैप सब्जेक्ट स्पेसिफिक होता है. जैसे आज हमने स्नैप लगाया थर्मोडायनामिक्स का. सेपरेटली यू कैन गो फॉर सम स्नैप रिलेटेड टू योर इंडस्ट्रियल ट्रेनिंग, some snap related to your experience if you are having some snap related to your B.Tech or M.Tech project. ठीक है?
Yes sir.
तो इनके बाद then you can go for your full mock, Raju. There are so many different mentors. You can join other mentors also for some snaps related to strength of material and introduction, HR part. ठीक है?
Okay sir. Thank you sir. Okay, thank you.
Raju, good luck. Best luck for your final interview.
Thank you sir.